welcome to Double Award Physics. This will be our last waves episode. The only thing we've left out is the electromagnetic spectrum. It's a learn me effort, so there's no point making a video on this. So this one is about the refraction in prisms. Okay, now a prism is cool because it can disperse light. Okay, and it's because of the fact that it's got oppositely slanty sides it's able to do this. So if I were to take just a regular ray of light, okay, what happens is when it strikes that surface like that, okay, so we kind of always start off with this slanty angle. If I draw my normal, which is like that, okay, that's the first difficult thing, is drawing the normal. Remember, it's at 90 degrees to the surface of the object. So if I just draw in that little 90, there it is there. Okay, there's 90 degrees. Okay, now remember our rules. It's going from a less dense material out here to a more dense material out here. So it wanted to go straight on, but it couldn't. It had to come closer to the normal, so it bends in this way. And it then goes and strikes this one over here. So we need a new normal over here. Okay, so that's like that. Again, 90 degrees. The ray of light wanted to go straight on, okay, because light travels in straight lines, but was compelled to move further away from the normal. Okay, so it had to come down this way. Now, this is the thing about prisms. Okay, when it comes here, it bends downwards and then downwards again. So it bends the same direction twice. Okay, that's kind of a feature of having these two oppositely slanty sides. Because it bends downwards twice, this can be used for separation. Okay, because this is a red ray, but let's imagine that we had a slightly different colored ray. So if I change the line style and I get a blue one in there, okay, if we were to send a blue ray along this line as well, okay, it would come in and strike exactly the same point as the red one, but it would be slightly more refracted, and would then strike over here and be slightly more refracted again. The result is that even though the two different colors came in together, they left in separate places and could be separated out. And this is what happens with white light. When white light comes in, it comes in as a single color because of the fact that they change speeds by different amounts. And here, they are refracted by different amounts. And as a result, they can be separated. So that's the key learning. Okay, white light is made of different colors. Apologies to our American viewers, but this is how you spell color. Deal with it. It also scores more points in Scrabble. A white light is made of different colors. Different colors change speed by a different amount. That's not how you spell amount. That's better. By a different amount when refracted. Okay. That's the exam mark there. Okay, different colors change speed by a different amount when refracted. They therefore refract by a different angle and are separated. Now we don't see this effect when we do the glass block one, because what happens is they come in and they're refracted and they separate. Well, they might separate out a little bit, but when they refract back the other way, because this one will refract a bit more, the ray ends up kind of becoming one ray again. Okay, so if I send the red and the blue in again, okay, the red refracts slightly less, okay, but because it refracts slightly less again on the way out, it very quickly forms back into a single ray again. Now this is heavily exaggerated. Okay, so the refraction or the recombining takes place almost instantaneously, so you don't see it. Okay, but in the prism, because they bend downwards twice, there's no ability for them to recombine, so the ray is separated out. Okay, and that's how dispersion happens. Okay, so once you get refraction happening twice in the same direction, we call it dispersion, because it can separate out and a ray that is a mixture of different colors or wavelengths or frequencies. It doesn't have to be light. It could be different radio waves. It could be different all sorts of waves. But primarily we're interested in prisms creating refractions that lead to a dispersion of light. Okay, and the order, of course, Richard of York gave Battle of Vane or Roy G. Biv. So bad it works. Red, orange, yellow, green, blue, indigo, violet, with red being least refracted and violet being most refracted. Remember, violet is very refracted. Okay, so it bends the most. there are other methods of learning that aren't appropriate for YouTube. Okay folks, thank you very much, and good luck in the exam.